Hello boys and girls, this is Mr. Giomini, a little bit of review from today's lesson on equivalent fractions. First I'm going to do some equivalent fractions with multiplication. We talked about two different methods today. We talked about multiplication and division. So I'm going to start with a fraction. It's already in simplest terms. I'm going to start with 2/3. So I want to create an equivalent fraction to 2/3. Since 2/3 is already reduced to simplest terms, all I'm going to do is I'm going to now multiply both the numerator and denominator by the same value. So I'm going to start with 2. So let's multiply both numerator and denominator by 2. So 2 halves. Now I just multiply straight across. 2 times 2 is 4. 3 times 2 is 6. So now I know that 2/3 is equivalent or equal to 4/6. 4/6 can be reduced down to 2/3. 2/3 can be multiplied by 2 to give me 4/6. So these two fractions are equivalent. Remember, I just multiplied both numerator and denominator by the same value. Let's try another example. Let's try something like 3/4. Okay, 3/4 is already reduced to simplest terms. I want to make an equivalent fraction for 3/4. So I'm going to multiply 3/4 by, let's go with something big. I'm going to go 4/4. Remember, whatever I'm multiplying by, it must be the same for both the numerator and denominator. You have to keep it the same. So now I just go and multiply straight across. 3 times 4 gives me 12. 4 times 4 gives me 16. I now know that 3/4 is equivalent or equal to 12/16. These are the same. If you think about it this way too, we'll have a little homework tonight. What did I do to 4 to make it 16? I multiplied it by 4. Whatever I do to the bottom, I do to the top. What if 3 times 4 gives you 12? So these are equivalent fractions. They're equal to each other. Let me get rid of this. Sorry about that. Okay, let's try another one. Let's try 17/29. Now this is a tricky one because 17 and 29 are both prime numbers. Their only factors are 1 in itself. So this is already reduced to simplest terms. I want to multiply both by, I'm just going to multiply both by 2. I want to find an equivalent fraction now. 17 times 2 gives me 34. 29 times 2 gives me, let's see, 9 times 2 is 18 in the ones place. Carry my 110. 2 times 2 is 4 plus 1 is 5. That's 58. So now I know that 17/29 is equal to 34, or is equivalent to 34/58. Okay. Now, why can't I multiply both the numerator and denominator by 1? Anybody know that? Why can't I just say, hey, I'm going to multiply numerator and denominator by 1? Think about that one for a second. Or why can't I multiply them both by 0? They're the same value. Answer that one to yourself there. Take a look here. Alright, now we have equivalent fractions with division. Now we have to know our divisibility rules. So this really becomes when we start to reduce fractions or simplify fractions. So now I'll start with something that needs to be reduced. So let's start with 15/24. Now, I need to think of a number that goes both into 15 and 24. I'm going to start listing my factors of 24. 1 and 24. Well, 1 goes in everything, so I can't include that. 2 and 12. Well, neither of those go into 15. 3 and 8. 3 goes into 15. So now what I do, instead of multiplying to find equivalent fraction, I'm going to divide both numerator and denominator by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. So now I know that 15/24 is equivalent to 5/8. If you want to think of it the other way too, what did I do to 24 to make it 8? I divided by 3. Whatever I do to the bottom, I must do to the top. 15 divided by 3 gives me 5. Okay. Let's go for another example here. Let's go with 10/45. Now I look at 10, I look at 45. 10 ends in a 0, 45 ends in a 5. Remember the divisibility rules. If a number ends in a 0 or 5, it's divisible by 5. So now I'm just going to divide both numerator and denominator by 5. 10 divided by 5 gives me 2. 45 divided by 5 gives me 9. I now know that 10/45 is equivalent to or equal to 2/9. And again, I could check this by saying, what did I do to 45 to make it 9? I divided by 5. What did I do to 10 to make it 2? I divided by 5. I could also go the opposite direction and say, what did I do to 2 to make it 10? I multiplied by 5, the inverse of division. Or what did I do to 9 to make it 45? I times it by 5, the inverse of division. Let's do one more example. I'm going to try this one here. Let's say I have 12 33rds is equal to 11. And here's my unknown. I'll put an x up here. There's my variable x. Now, so 12 33rds is equivalent to or equal to how many 11ths? I'm going to take what I know. I see that I'm getting smaller, so we're equivalent fractions with division, so I'm going to divide. What do I divide 33 by to get 11? I'm going to divide by 3. So whatever I do to the bottom, I must do to the top. I divide this by 3. 12 divided by 3. What is 12 divided by 3 or 4? The opposite, the inverse. 4 times what? Or 3 times what? Just to give you the answer divided by 3. That gives me 4. So my equivalent fractions would be 12 33rds is equivalent to 4 11ths. Hope that helps you out, and we will talk to you later today. Bye-bye.